Okay, we're going to look at section 3.7 and find out how do you find the determinant of a matrix. So in order to find the determinant of a matrix, we need to have the same number of rows as columns in the matrix. So basically, they need to be square matrices. Okay, and a determinant is just a number. Okay, a number determined by the matrix. You'll see how we find that. And a determinant is used to solve systems of equations. It also has some other applications. One we will see later in this section. So let's start with a 2 by 2 matrix. Those are real easy to find the determinant. In general, looks like this. The determinant of a matrix with 4 entries. In general, if the entries were A, B, C, and D, you take the product of these two numbers and subtract the product of these two numbers. That's your determinant. Okay. A 3 by 3 matrix is a little more difficult. I'm going to refer you to the book on page 203. Looks something like this. Okay. And here again is the 2 by 2. A 3 by 3, what you need to do then is, in general, we take the 3 by 3 matrix, we rewrite the first and second column again, and we multiply. So we multiply these 3 numbers in a diagonal. So we start with the top left and we move to our right. So we have 3 different multiplication products that we add together. And then we start in the bottom left and multiply those 3 diagonals together, and we find the difference, we subtract. So let's just do a couple examples. Okay, so here's the first one. I believe it's the same example in your text. So we start in the top left, we multiply 5 times 1, and we subtract the product of the other diagonal here, 3 times 4. So you got 5 minus 12 equals negative 7. So the determinant of that matrix is negative 7. Okay, 3 by 3, little longer process. So we start by rewriting the first 2 columns. And then we start multiplying. So we multiply, start in the top left, we multiply 2 times 1 times negative 2. So you got 2 times 1 is 2, times negative 2 is negative 4. I like to write them just below here. Okay, then you go negative 1, 0, and 3. Anytime I have a 0, product is going to be 0. That's nice. And then finally this one, negative 3 times positive 4 times negative 4. So we have 2 negatives, so the result's going to be positive. So 3 times 4 is 12. And times 4 is 48. Okay, so I add those 3 numbers up, and I get 44. Now I start here, bottom left, multiply those 3 numbers. 3 times 1 times negative 3 is negative 9. Multiply these 3 numbers, I get a 0 there, so that's 0. Multiply those 3 numbers, I get negative 8 times 1 is positive 8. Add those 3 numbers up, and I get negative 1. So now I take the product of those first 3 and subtract the product of these 3 diagonals. Always be careful with your sign, because if I have negative here, it's going to become an addition there. So I get 45 as my determinant. Okay, so it's a little longer process. You got to be a little careful with your signs. Okay, so what I would suggest is you try these 2 and pause the video and see if you get the right answer, and then I'll work you through it. Okay, so the 2 by 2, let's see, we got 3 times 1 is 3, minus 6 times 2 is negative 12, so 3 minus negative 12 is 15 on that one. The 3 by 3, let's rewrite the first column. Start in the top left, multiply those 3 together, I get negative 8. Multiply these 3 together, I like having zeros, gives me a 0. Multiply those 3 together, let's see, 5 times 2 is 10, times negative 3 is negative 30. So add those three, I get negative 38. Start over here. Multiply those three, I get 0. Multiply these three, I get negative 20. Multiply these three, I get 3. So that adds up to negative 17 on this side. So I got negative 38 minus negative 17. And that's going to give me, that's going to be a plus, so that's negative 21. Okay, so that's how we get those for a 2x2 and a 3x3. We're not going to go any bigger at this time. Okay, so one interesting application is we can use this for solving areas of triangles. Okay, and if you look on page 204 in your text, which I'll pull up here, it gives you the formula here. It says the area of a triangle, if we know the three vertices of the triangle, can be found using this formula. Plus or minus 1/2 times these lines mean it's the determinant of this matrix. So we enter in the coordinates of the matrix, and it doesn't matter which order you put them in, and then the last column is just ones. That's always ones. The reason for the plus or minus is to make sure your area always ends up being positive. So if you end up with a negative determinant, you multiply it by negative 1/2, so you have a positive result. Okay, so in the past, if I have three unique coordinates of a triangle, it's kind of difficult to find the area of that triangle. Okay, but this allows us, gives us a little easier way. So if you look at example 2 in your text, I have a pretty good example here where this could be useful. A big triangle here. So you've got an area off the Pacific Ocean, and you've got the coordinates there of 3 locations, and this I believe is in miles. Okay, so we have 3 coordinates: 0, 0, negative 1, 41, 38, negative 43. If I had to find that using normal triangle formulas, 1/2 base times height, it'd be a little difficult to find. But entering into the matrices here and finding the determinant is fairly quick and easy. We just enter in the 3 coordinates here, find the determinant, and then multiply it by 1/2, and you get the area of that triangle. So let's try one here. Find the area of a triangle with these 3 vertices. Okay, so if you want, you can pause that and give it a shot. Then I'll do it. Okay, so let's see the area. Plus or minus 1/2 times the determinant of this matrix. So let's put 5, 11, 9, 2, and 1, 3, and then the last one is just ones. So to find the determinant, I have to rewrite the first 2 columns again. So let's start multiplying that diagonal. It's 10. That diagonal is 11. And this diagonal is 27. Add those up. So what do we get? 48. Okay, start in the bottom left now. Multiply those 3. I get 2. These 3 gives me 15. These 3 gives me 99. So let's see, that's going to give me 116. Okay, so let's see, I'm going to have plus or minus 1/2 times, I got to take this minus this. Let's see what I get there. So 48 minus 116. 68. So I got plus or minus 1/2 times negative 68. So because I have a negative determinant, I multiply it by negative 1/2, so I get a positive area of 34. So the area of that triangle with those 3 vertices is 34. So that's just one application for determinants. Another application in your text is Cramer's rule. We're not going to cover that at this time, but if you want to look at it in your text, you can and see how you can solve a system of equations using determinants.